We are going to discuss vertical asymptotes and the relationship between end behaviors and vertical asymptotes. So when we are looking at our vertical asymptotes, we may have more than one within our graph, and we're going to look at what happens as our function approaches the asymptote, otherwise known as the limit, from the left side as well as from the right side. So when we are approaching the asymptote known as a, so in this case x equals a, from the right side, you'll notice the notation we're going to use is the limit as x approaches a, which is the asymptote. The plus sign represents the right side. So what's going to happen is either our function is going to approach infinity or it's going to approach negative infinity. And then as we approach our asymptote from the left side, which is used for the negative symbol, once again, we're going to look at what happens to our function as we approach it from the left side and the right side. So just remember that vertical asymptotes are when the denominator of the function is 0, as long as the numerator is not 0. So you may have some number over 0, or an equation over x minus 4. So what values of x would make the equation 0? Okay, so here we have y equals 4 over x minus 3. We are going to determine all possible asymptotes, and we're also going to sketch this function. So when we look at this function, we have 4 over x minus 3. First thing we're going to do is think about the asymptotes. If we think back to the last lesson, we can determine the horizontal asymptote. How? So to determine the horizontal asymptote, we're going to look at 4 over x minus 3. Now, when we're looking for horizontal asymptotes, remember y will equal 0 if the degree in the denominator is higher than the degree in the numerator. In this case, the degree in the numerator is 0, whereas in the denominator it's 1. So we're going to have a horizontal asymptote at y equals 0. Our vertical asymptote, well, what number will give us a value of 0 in the denominator when x is equal to 3? Okay. So we're going to now sketch the function. When we're sketching the function, it does not need to be exact. However, we know the asymptote, so that's the first thing we're going to sketch. So we know we have a horizontal asymptote at y equals 0. We know we have a vertical asymptote at x equals 3. So now what we're going to do, we're going to sub in a few values. We can sub in the value 1 and we can sub in 4. We want to sub in some values that are on either side of the asymptote. So if we sub in 1, we're going to get the point 1, negative 2. And if I sub in 4, I'm going to get 4, 4. So 4, 4 is here. And then 1, negative 2 is here. You can check other points as well to help you. And as you sub in other points, you're going to get someone like this. for your curve. Somewhat like this for your curve. Now, as we look at our function, what happens as we approach our asymptote of 3 from the left side? So as we approach from the left side, what's happening to the y values? What are they going to approach? They're going to approach negative infinity. So we would state that our function is going to approach negative infinity. What about if we approach the asymptote from the right side? As we approach from the right side, what happens? It's going to continuously increase, so positive infinity. Okay, let's try another one. This time we have the function y equals negative 2x plus 4 over x minus 3. And we're going to determine all the possible asymptotes as well as sketch the function. So for this one, notice we have the same degree in the numerator as the denominator. So what would our horizontal asymptote be? It's going to be negative 2 over 1, which is at y equals negative 2. For our vertical asymptote, the value 3 would make it 0. So when we're sketching, so we know we're going to have our horizontal asymptote at negative 2 this time. So here. And we have a vertical asymptote at 3. So here. And then we can check points surrounding our vertical asymptote. So we can check at 2. So if we sub in 2, we get 0. And we can check 4. And we get negative 4. So 2, 0, and then 4, negative 4. And then you can check other points as well, but you're going to get a curve somewhat like this. And like this. So, what happens as we approach our function from the left side? So if we approach from the left side, as it approaches the asymptote, it's going to continue to increase and approach infinity. So we'd say the limit as x approaches 3 from the left side equals infinity. And then as we approach from the right side, what happens? It's going to continue to decrease. So we would say the limit as x approaches 3 from the right side is going to be negative infinity. So as you're sketching, you'll get the hang of it, and you'll notice with specific functions, you'll know right away what type of functions you're going to have, because you'll be able to recognize how many asymptotes you have, where they are, what the behavior of the function is going to look like. So next we have y equals 4x minus 4 over 2x minus 2. they are the same degree. So for our horizontal asymptote, we're going to have the coefficient, so 4 over 2, which is 2. So you have a horizontal asymptote at y equals 2. Okay. Now for vertical asymptote, well, it says 2x minus 2, if we make that to 0. So x equals 1. However, what we can do here, notice, we can factor this. And I want you to notice what happens when we factor. So I have 4, and then x minus 1, 2, and then x minus 1. What do you notice? We can cancel these both out, which means there is a hole. So rather than there being a vertical asymptote at x equals 1, there's going to be a hole at x equals 1. So let's see what that looks like. So we have our horizontal asymptote at 2. And then this function is actually y equals 4 over 2, or 2. So what does y equal 2 look like? That's a line. It's a horizontal line. So if I were to plot this line, well, it actually occurs on the asymptote. So the line is going to trump the asymptote, but we also said there's a hole. So when we're drawing our function, if there's a hole at x equals 1, that means that here, the function doesn't exist. There's a break. It's not continuous. So we would draw a horizontal line with a hole. Okay. So this time we have y equals x squared minus 4 over x minus 1. Do we have a vertical asymptote? So there's a vertical asymptote at x equals 1. Do you have a horizontal asymptote? So the degree in the numerator is higher than the degree in the denominator, so we do not have a horizontal asymptote. However, notice the degree here is 2, the degree here is 1. What happens when the degree is exactly 1 higher? Well, let's find out. So if we recall, we're going to have an oblique asymptote. Well, what is that oblique asymptote? So in order to find oblique asymptotes, remember we're going to divide. So we have the function x squared minus 4 divided by x minus 1. We cannot simply take x squared minus 4 because we're missing an x value. So if you recall, we need to use a placeholder. So we have x squared plus 0x minus 4. That's being divided by x minus 1. So when we divide, so we're going to get x, and then we multiply, we get x squared minus x, then we subtract, and we end up with 1x. Then we bring down the 4, and then we divide, we end up with 1. So what we end up with here, that is our oblique asymptote. So our quotient is the oblique asymptote. So when we sketch this function, we have an oblique asymptote at y equals x plus 1. We know that's a diagonal line with an intercept at 1. So, and a slope of 1. So there is my oblique asymptote. And then when we draw our function, if we sub in some points here, so say I sub in the point 2, and I get 0. If I sub in -2, I get 0. And then you can sub in more points to check what it's going to look like. Now don't forget, we have a vertical asymptote at x equals 1. So our function is going to look somewhat like this. And there you go. Now we have graphed the reciprocal functions.